by the action of an electric current on a conductive material immersed in a solution containing a salt of the metal to be deposited, which is a very fancy way of saying that coating of a metal on top of another metal by electrochemical reduction of metal ions. It is normally done for corrosion resistance and for decoration. It is highly preferable for the thin films. A great example of this method is that this method is used for car painting. From the second figure on the bottom, cars are passed from one side to another, immersing in the painting liquid. Direct current is passed through car bodies. This method is widely used for car painting nowadays. How does electrodeposition work? Metals which have to coat act as cathode and the metal which will be plated acts as anode. The solution is called electrolyte. The reaction occurs between electrodes and electrolytes. The main conditions for electrodeposition of alloys is deposition potentials of metals should be fairly close together. Also, noble metals deposit easily while it is hard to deposit active metals. Co-deposition will occur if the voltage difference is less than 0.2 volt, although there is some exceptions. Zinc nickel can be deposited though their voltage difference 0.5 volt. Silver palladium cannot deposit though their voltage difference nearly same. Rule of EMF series in electrodeposition is very peculiar, hence it is not too reliable. EMF series states that metals with electrode potentials more negative than hydrogen could not be deposited from aqueous solution, which is not right. Why more negative metals than hydrogen can be deposited? While electrodepositing, applying over voltages change the position of hydrogen. Hydrogen becomes negative and stays between aluminum and manganese, thus enable a lot of metals to deposit. This existence, the existence of this phenomenon is fortunate for electrodeposition because the majority of the metal in which electroplaters are interested have potentials less noble than that of hydrogen. There's one exception though. Cobalt is less noble than vanadium, molybdenum, germanium, or tungsten, but cobalt actually deposits faster than this. None of these metals have been deposited from aqueous solution in pure state. Hence, EMF series is not too reliable. Principles of alloy electrodeposition. Despite our trying, it is not possible to bring two metals potential exactly same. One will be slightly active than other. Let us consider copper zinc deposition. Copper is slightly active than zinc. So if they stay in the bath, a layer of copper will deposit fast, making slightly reduced copper concentration. So zinc will act as active metal and a layer of zinc will deposit again. Now, this type of coating is not good. So we have to maintain copper zinc ions ratio. So here we have our first rule, which is if a plating bath is replenished with two metals at a constant ratio, the ratio of metals in the deposit will be constant. An increase in metal-metal ratio in bath also increase metal-metal ratio in coating. In our previous cases, copper zinc ratio, let's say copper zinc ratio is 1. If we will now make it to 2, copper zinc ratio in coating will increase. Both of concentration of more readily depositable metal to the other is smaller at cathode solution interface than in the body of the bath. Let's explain this with copper zinc alloy. Copper ions preferentially deposit at cathode surface than zinc ions. So copper ions will be less at interface and it will diffuse at bulk to come to at the interface. Concentration of metal ions at cathode solution interface tends to approach metal mutual equilibrium with respect to the parent metals. Let's consider two alloys, copper, zinc, and tin and lead. In both cases, a few amount of copper and lead ion will go to interface. Copper is more noble than zinc, while tin and lead potential is very close. So less amount of copper will deposit at the interface than lead. So to go equilibrium, copper ions will have to go to the interface from body faster than lead ions.
4 minutes.
A variation in plating conduction that brings E value closer together will increase less noble metal in the deposit. By changing some parameters like agitation or temperature, two metals potential could bring close together. To keep the number 6 is that to keep position same, we have to follow two rules. Constant voltage if uncontrollable variables affect potentials of more noble metal. Constant current density if uncontrollable variables affect voltage of less noble metal. Advantages of alloy electrodeposition: increased corrosion resistance, low cost and industrial applicability, high production rates, new properties like constituents, ability to produce composition unattainable by other techniques. And disadvantage of alloy electrodepositions are that high difficulty of reproducing alloy composition, high risks of hydrogen embrittlement, toxic plating solutions, greater control required in this process. So this was my presentation. Thank you.
তুমি ওই সবাই দেখছি অ্যালয় প্লেটিং সিস্টেমটা বাদ দিয়ে যাচ্ছে।
স্যার এই টপিকটা অনেক বড় আর কি, এই জন্য সব ইনক্লুড করতে গেলে আসলে হয় না।
তুমি প্রথম দিকে এত ডিটেইলস বলার দরকার নেই তো, এত ডিটেইলস কেন বলতে যাবা? তুমি একটা আর্টিকেল বাদ দিয়ে যাচ্ছ আর আরেকটা আর্টিকেলকে একেবারে ইনডেপথ স্টাডি করছো, দরকার নেই, তুমি টাচ করে যাবা,
জি
ঠিক
স্যার।
আছে?
জি স্যার।
আর আচ্ছা আচ্ছা, মাইকগুলো তোমরা বন্ধ করো, তোমার এই স্ক্রিন স্লাইড অফ করো, স্লাইড, সবাই মাইক বন্ধ রাখবে। আর 30 মহিদ হাসান, তুমি কি প্রেজেন্টেশন দিবে? মহিদ হাসান, মহিদ হাসান আছো? 30 তোমার তো থাকার কথা, কই? হ্যাঁ মহিদ হাসান আছো তো? হ্যাঁ মহিদ হাসান প্রেজেন্টেশন দিবে? ও হাত উঁচু করেছে কিন্তু কিছু বলছে না কেন? ও সরি। হ্যাঁ এখন পারবে মোহিত, এখন পারবে।
স্যার আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম।
স্যার
তুমি
আমার
প্রেজেন্ট, হ্যাঁ শব্দ হচ্ছিল বলে আমি সবাইকে মিউট করে দিয়েছিলাম। হ্যাঁ তুমি দিবে আজকে?
না স্যার
আচ্ছা
আজকে
ঠিক
স্যার
আছে,
পারবো না।
ঠিক আছে। 31
जी सर।
ফারিয়া হাসান ভুইয়া, কি ফাহারিয়া
जी सर।
হাসান ভুইয়া। হ্যাঁ শুরু করো, তোমার স্লাইড শো দেখাও। কই ফারিয়া হাসান?
हेलो सर।
হ্যাঁ কি হচ্ছে?
सर আমার নেটে প্রবলেম হচ্ছিল স্যার, আমি আবার শেয়ার করছি। স্যার স্ক্রিন কি দেখা যাচ্ছে এখন?
হ্যাঁ যাচ্ছে, হ্যাঁ
আচ্ছা।
স্লাইড শোতে যাও, ফুল স্লাইড শোতে, হ্যাঁ শুরু করো।
Hello everyone, my name is Fahri Hassan Bhaiya and this presentation is then a single metal, but alloy
শোনা যাচ্ছে না, অন্যরা শুনতে পাচ্ছ? ফারিয়া
স্যার
হাসানের, ফারিয়া হাসান তোমার কথা শোনা যাচ্ছে না।
স্যার ইন্টারনেট চলে গেছে মনে হয়।
আচ্ছা ঠিক আছে, নেক্সট শুরু করো, 33
স্যার
শুরু
আমি
করো।
জি স্যার থ্যাংক ইউ
33
স্যার হুম,
আবরার ওয়াসিফ, শুরু করো তুমি।
জি স্যার
আবরার,
আমি শুরু করতেছি,
হ্যাঁ
শেয়ার করতেছি। স্যার দেখা
হ্যাঁ ফুল স্লাইড শোতে যাও। Okay, start.
Hello guys,
শুনতে পাই না। আমরা শুনতে পাই না। তোমরা শুনতে পাও? অন্যরা?
না স্যার।
কি ব্যাপার, সবারই এক এক কি সমস্যা হচ্ছে? ওর কি ইন্টারনেট চলে গেছে? আবরার শোনা যায়? ওকে, 34 রেডি করো। 34 সিরাজুম মনিরা।
Yes, sir.
হ্যাঁ, তুমি শুরু করো।
hello.
হ্যাঁ আবরার, তুমি পরে। সিরাজুম মনিরা শুরু করো। সিরাজুম মনিরা রেডি আছো?
Yes, sir.
হ্যাঁ শুরু করো। আবরার পরে আসো।
Hello, everyone. I am Sirajum Monira and I am presenting electrodeposition of alloys. So the general procedure of electrodeposition for a single metal and an alloy is exactly same. That is, current passing through a electrode to solution, and as a result, the deposition of metal upon the cathode occurs. To ensure simultaneous deposition of two or more metals, we need to electrolyze a bath of metallic salts at sufficiently high current density. But the deposit obtained are usually loose, spongy, and with non-adherent masses, which is not our type of interest. So the preliminary and obvious requirement for the deposition of alloy is at least one of the metals should be individually capable of being deposited. So the most important and practical consideration is deposition potential of metals should be fairly close together. But why? That's because we know that more noble metal deposits preferentially. So if we want to simultaneously co-deposit two metals, the condition must be such that more negative potential of the less noble metal can be attained without employing excessive current density. So here we can see the table of standard electrode potential. Data of this EMF series apply only to the equilibrium potentials of the metals in solution, but the limitation of it is deposition potentials generally are more negative than the standard potentials. Also, we know that from that the metals with E value less than hydrogen cannot be deposited from aqueous solution. But these metals can deposit from solution because hydrogen deposits at much more negative potential than its equilibrium value, which is known as hydrogen overvoltage. And this phenomena is generally fortunate because most of the metals used for electroplating, these have lower potential than hydrogen. Also, there is another exception, that is cobalt. Though cobalt has more negative potential than vanadium, molybdenum, germanium, and tungsten, but it can readily deposit it in pure state, which these metals can't. So here are the equations of static potential and deposition potential. So if we want to co-deposit two metals, the condition should be the deposition potential of both would be equal. So from this equation, we can conclude that we can satisfy this equation by two ways. The first way is selecting metals so that their standard equilibrium potential is equal, like thin lead alloy. Here we can see their standard equilibrium potential. Also, if the difference of the standard equilibrium potentials is less than 0.2, then co-deposition is generally easier. Then adjusting activities, and this can be obtained by adding complexing agents like cyanide, halide, and amphoteric oxide, etc. Its example is lead silver alloy. In this alloy, the concentration of silver is decreased by used cyanide complexing. Here are the principles of alloy deposition. The first principle is if we can maintain a constant ratio in the bath of the metals, then the ratio of the metals in the deposit will be the same. And how we can obtain the constant ratio? We can do that by using consumable anode or constantly adding metallic salts. The second one is increasing in metal percentage or ratio in bath results in increase in metal percentage in deposit. And the third one is variation in plating condition that brings potential values closer together. Here are the fourth and fifth principle, and these two together creates this. And here the Cm is the concentration of more readily depositable metal at cathode solution interface.
4 minutes.
And Cm naught and Cn naught are more and less readily depositable metal in the bath body. Here is the sixth principle, and it has two parts or two conditions, which are constant E or constant current density for less noble metal and constant E for more noble metal. Here are the advantages, which are increased corrosion resistance, new properties, combination of properties, or tailor-made properties, and these are the disadvantages, like greater control required or greater attention required, or it is difficult to reproduce the alloy composition. So the variation of bath composition depends on these variables. Also, bath operations variables are these: current density, temperature, agitation of bath, etc. There are also some miscellaneous variables like cathode current efficiency, shape of cathode, type of current, etc. And here are the types of alloy plating system.
স্টপ, তুমি দেখিয়ে যাও, স্লাইড গুলো শুধু দেখিয়ে যাও। ঠিক আছে, তুমি সব ইনক্লুড করেছো, কিন্তু সময়ে তোমার কুলিয়ে উঠতে পারলে না। যেটা করতে হয়, সব ইনক্লুড করতে হয় প্রেজেন্টেশন রেডি করার সময়, কিন্তু টাইমের সাথে মানিয়ে চলতে হয়। আবার তুমি যখন দেখবা যে তুমি কমপ্লিট করতে পারবা না সেরকম মনে হলে, তুমি যে স্লাইড তুমি দেখাচ্ছ ওই স্লাইডের সংক্ষিপ্ত আকারে বলে যাবো, অথবা এমনও হতে পারে দু একটা স্লাইড যেটাকে তুমি লেস ইম্পর্টেন্ট মনে করছো এটাকে তুমি বাইপাস করে যেতে পারো, শুধুমাত্র দেখিয়ে চলে যেতে পারো। এমন না যে সব স্লাইড গুলোই বলতে হবে। বোঝা গেছে সিরাজুম মনিরা?
জি স্যার।
হ্যাঁ, তোমাকে টার্গেট করতে হবে তুমি শেষ স্লাইড পর্যন্ত পৌঁছাবা। এর জন্য যদি মাঝে দু একটা লেস ইম্পর্টেন্ট স্লাইডকে স্কিপ করতে হয়, স্কিপ বলতে শুধু দেখিয়ে যাবা, কিছু বলার দরকার নেই, সেটাও করতে হবে। তোমাকে অ্যাডজাস্ট করে চলতে হবে। ঠিক আছে, ভালো হয়েছে, তবে কমপ্লিট করতে পারলে আরো ভালো হতো। ওকে, থ্যাংক ইউ। তোমার রোল নাম্বার 34, তাই তো?
জি স্যার।
35 তোমরা সবাই থাকবা, যাদের শেষ হচ্ছে তারা সবাই থাকবা।
হ্যালো স্যার, শোনা যাচ্ছে?
হ্যাঁ, 35
জি স্যার।
মশিউর রহমান মেনন, শুরু করো।
স্যার ওই শেয়ারিং
শেয়ারিং অফ করো, শেয়ারিং অফ করো সিরাজুম মুনিরা। হ্যাঁ, মশিউর রহমান মেনন, শুরু করো।
জি স্যার। স্যার দেখা যাচ্ছে?
না, এখনো দেখতে পাচ্ছি। হ্যাঁ, এখন দেখা যাচ্ছে। ফুল স্লাইডে যাও।
অপশন আমি দেখিয়ে যাই। অপশনটা আমি আসলে এখন ঠিক খুঁজে পাচ্ছি না, দেরি হয়ে যাচ্ছে। Okay, hello everyone. Assalamu alaikum. I'm Mohammad Mushir Rahman. Today I will discuss about electrode deposition of alloy. So let's go to the first slide. Okay. So the first thing is general condition for electrode deposition of alloy. The procedure is almost same with depositing a metal where current flows from electrode or through solution and the metal deposits upon the cathode. But there is a problem to get the deposit down strong homogeneous. If we pass current through bath with mixed metallic salts, the deposits will be loose from the non-adherent masses contaminated with basic inclusions. So to discuss of the preliminary condition, at least one metal or more is capable of being deposited from aqueous solution, and the other is their potential be fairly close together. That's said on the first slide. So the next one is six principle of alloy. The six principle alloy deposition are: first one is if an alloy plating bath, which is a continuous operation, is replenished with two metals in a constant ratio, that is m by n, the ratio of the metals in the deposit will approach and ultimately take on the value m by n. And the second one is an increase in the metal percentage or ratio of a parent metal in an alloplating batch results in an increase in its percentage or ratio in the deposit. Third one is in alloy deposition, the ratio of the concentration of the more readily depositable metal to the other is similar at the cathode solution interface than in the body of the batch. Fourth one, in the deposition of alloys from the normal alloy plating system, the fundamental mechanism is the tendency of the concentration of mutual equilibrium. Mutual equilibrium with respect to the two parameters. Both principles 3 and 4 lead to the relation C sub m by C sub n less than C sub with sub m by C sub 0 O by n. And the fifth one is a variation in a plating condition that brings closer together the potential for the deposition of the parent metals separately. That is decrease the interval of potential between them, increase the percentage of the less noble metal in the electrodeposition alloy and vice versa. And the last one is in depositing alloy, in which the content of the less noble metal increases with current density. The operating conditions for obtaining the more constant composition of deposit are constant potential is the uncontrollable affect the potential of the more noble metal, and the second one is constant current density is the uncontrollable variable affect the potential of the less noble metal. And the next topic is we got some advantages and disadvantages of alloy deposition. So the advantages are increased corrosion resistance due to the greater density and finer grain structure. Second one is combination of properties of the individual constituents. Third one is new properties unlike the individual constituents. Fourth one is tailor-made properties which you want or specified by proper selection of the constituents. And some disadvantages also. First one is the greater control required. Second one is the difficulty of reproducing the alloy composition, and the third one is the greater attention to the anode system used and the effects on the solution constituents and its complexes. There is the composition of an electrodeposited alloy is a function of a large number of variables. The main ones of which are as follows: plating variables, variables of batch operation, miscellaneous variables. Okay, plating variables, which is few parts, variables of batch composition, concentration of complex agents, pH of plating batch. Fourth one is presence of addition agents, presence of indifferent electrolytes or conducting salts. Variable of batch operation, which has also some parts, current density, temperature, excitation of batch or movement of cathode. And the last one, miscellaneous variables, cathode or current efficiency, shape of cathode, basis metal. Okay, the organization, presentation, and theoretical discussion of data are greatly simplified by dividing all of the alloy plating process into 5 steps. These are regular co-deposition, irregular co-deposition, equilibrium co-deposition, anomalous co-deposition, and induced co-deposition. The explanation of these 5 steps are given. That is regular co-deposition. It is being under diffusion control. The percentage of the more noble metal in the deposit is increased by those agencies that increase the metal ion content of the cathode diffusion layer. Agencies like decrease of current density.
4 minutes.
Of lead.
Okay, go ahead. 4 minutes.
It is controlled by the potential of the metal. The effects of plating variables on the composition of the deposit are much smaller. The example of this system is external zinc. Equilibrium co-deposition, it is kind of deposition from a solution which is in chemical equilibrium with both of the parent metal. Copper based deposition from an acid base is the example of this deposition of this system. Sorry. Okay, anomalous co-deposition. It is characterized by the anomalies that the less noble metal deposits preferentially. This system is rather rare. Zinc nickel deposition is the example of this type, and the last one is induced co-deposition. It is characterized by the deposition of alloy containing metals such as molybdenum, tungsten, germanium, which cannot be deposited alone. However, these metals readily co-deposit with the iron groups. That's the end of my slide. Thank you, everyone.
থ্যাংক ইউ, তুমি সবকিছু কভার করেছো একেবারে এক্স্যাক্টলি 5 মিনিট 4 সেকেন্ডে। কিন্তু যেটা হচ্ছে তোমাকে স্লাইড গুলো আর একটু আকর্ষণীয় করে তুলতে হবে। হ্যাঁ, তুমি খবর পড়ার মতো সব লিখেছো এবং খবর পড়ার মতো রিডিং। হ্যাঁ, কি আছে? বুঝিনি, আবার বলো।
থিওরির দিকে একটু বেশি নজর দিতে, যাতে এগুলো একটু ক্লিয়ার করে বলা যায়।
হ্যাঁ, কিন্তু তোমাকে প্রেজেন্টেশন আর একটু ইজিয়ার করে দিতে হবে। প্রেজেন্টেশনের সময় যেটা তোমাকে থাম্ব রুল মনে রাখতে হবে, যেন তুমি মনে করবা যে অডিয়েন্সকে তুমি বোঝাচ্ছ সে অডিয়েন্স কিছুই জানে না। অতএব যত সহজবোধ্য করে তুমি বোঝাতে পারো। হ্যাঁ, তুমি যদি একটা প্যারা লিখে সেই প্যারাটা রিডিং পড়ে যাও, অডিয়েন্স কিছুই বুঝবে না। তোমাকে ধরে নিতে হবে যে অডিয়েন্স একেবারে বকলম এ ব্যাপারে। এখন তুমি যত সহজবোধ্য করে বোঝাতে পারো, লেখা কম থাকবে, ছবি বেশি থাকবে। হ্যাঁ, তারপরে যখন তুমি যে কথাটা বলবা তখন যেন অডিয়েন্সের দৃষ্টিটাকে সেখানে নিয়ে যেতে হবে, এই জন্য তোমাকে অ্যানিমেশন ইউজ করতে হবে। তোমার লেখা অনেক বেশি, ওই যে তুমি যেটা বললে থিওরিটিক্যাল, মানে একটা লিটারেচার রিভিউ এর মতো যেন তোমার লেখা আছে এবং তুমি সেটা রিডিং পড়ে গেছো। আমি জানি ব্যাপারগুলো, আমি বুঝেছি। আমি যদি না জানতাম, এখান থেকে কিছু উদ্ধার করা, কিছু শেখা আমার পক্ষে মোটেও সহজ ছিল না। হ্যাঁ, তবে পজিটিভ সাইড যে তুমি 5 মিনিটে, যে এক্স্যাক্টলি 5 মিনিটে পুরোটা কভার করেছো। ওকে, থ্যাংক ইউ ভেরি
থ্যাংক ইউ
মাচ। 31-এ চলে, 31, রোল নম্বর 31।
জি স্যার।
31 এখন তুমি শুরু করো। আবার 0 থেকে শুরু করো।
Hello everyone, my name is Fahri Hassan Bhia and this presentation is about alloy electrodeposition. So electrodeposition is basically the formation of metallic coating on a substrate material. It is also known as electroplating or electrocrystallization. Besides the formation of metallic coatings, electrodeposition is also used to extract certain metals such as aluminum or magnesium, etc. So here are some examples of electrodeposition of metal. Note that only one single metal is being deposited in these cases. Now the idea of depositing two or more metal is interesting, as we know that alloy exhibit wider spectrum of properties than a single metal. But then again, alloy electrodeposition is technically more complicated, and because it requires more stringent control of the composition of electrolyte and other depositing parameters, and also close monitoring of these parameters. So electrodeposited alloy should have better properties than a pure metal to compensate for this increased difficulty. Enhanced properties are finer grain, increased hardness and strength, and more resistance to corrosion. And they may also exhibit some special properties such as high magnetic permeability, which is not shown by the parent metal. So conditions for electrodepositing alloys. One requirement is that at least one metal should be capable of being deposited individually from solution, and co-deposition will occur if their deposition potential are close. And we know that more noble metal deposit preferentially, and the less noble metal is sometimes excluded from deposition. Rule of static potential. From standard electrode potential data, we can gain a general idea if two metal will co-deposit or not. So this is the table for standard electrode potential, and this series suggests that vanadium, molybdenum, germanium, or tungsten is more easily or readily deposited from solution than cobalt, but in the opposite scenario is observed. So this series might not always be too reliable in practical cases. So as a rough guide, to co-deposition will occur if the static potential of the metals are not over 0.2 volt apart. But there are also some exception to this rule, and I've given here 2 examples. Our aim is to bring static potential of the two metals as close as possible. Static potential is given by dissipation, and the actual deposition potential is static potential plus some irreversible effects. How can we bring static potential closer? In order to co-deposit two metals, this equation here needs to be satisfied, and it can be done in 2 ways. First, we can choose metals that are placed together in EMF series, and second, by adjusting the activities of metal ions in the bath. And now Nernst equation shows that a reduction in activity corresponds to a potential shift in the negative direction, and an increase in ion activity moves the potential to more positive values. So by adding complexing agents in solution, we can reduce the ion activity in more noble metals. For example, during silver lead co-deposition, activity of silver ion is lowered by introducing cyanide in the bath solution. Most common complexing agents are cyanide, although it is severely poisonous, halide and amphoteric oxides like stannate. Now there are 6 principles of alloy deposition. I will explain 1 or 2. The first one states that if an alloy plating bath is replenished with two metals at a constant ratio m/n, ratio of the metals in the deposit will be m/n. So for example, in brass deposition, if we want the coating to be of homogeneous composition across the whole cross section, say 70-30, we'll have to maintain the ratio of copper and zinc exactly 70-30 in the bath. Now the second principle states that an increase in metal percentage or ratio in bath results in an increase in percentage of ratio in the deposit. So for example, I have two deposition systems of the same alloy, say brass. So now according to this principle, if one of the system contain more copper than the other one, then the coating of that system will also contain more copper. And now I'll just read out the rest of the principles. Principle 3 says ratio of the concentration of more readily depositable metal to the other is smaller at the cathode solution interface than in the body of the bulb. Concentration of metal ions at cathode solution interface tends to approach mutual equilibrium with respect to the parent metals. Fifth principle states that
4
brings
minutes.
E value closer will increase percentage of less noble metal in the deposit. And the last one suggests that in depositing alloys in which content of less noble metal increase with current density operating conditions for obtaining more constant composition of depositor, a constant potential if the uncontrollable variable affect potential of the noble metal, and constant current density if the uncontrollable variables affect potential of less noble metal. What are the advantages of alloy deposition? The advantages are a combination of properties of the two parent metals, increased corrosion resistance, new properties that is not present in any of the individual metal, parent metal, and we can also tailor some new properties.
ওকে স্টপ, স্লাইডগুলো দেখে যাও। হুম,
So এতটুকু ছিল।
আচ্ছা ঠিক আছে, তোমাকে আরো ইমপ্রুভ করার সুযোগ আছে। তুমি ওই অ্যানিমেশনটা মনে হয় ইউজ করনি, করেছো?
না স্যার,
অ্যানিমেশন ইউজ করবা, তাহলে বুঝতে সুবিধা হবে। হ্যাঁ
জি স্যার।
33.
Yes, sir. I am ready to share my slide. Sir, দেখা যাচ্ছে?
হ্যাঁ যাচ্ছে।
Sir, my name is Mohammad Ambar Wasit. I am here to present my slide about topic alloy electrodeposition. So now let's start. On alloy electrodeposition. Alloy electrodeposition represents a particular case of simultaneous occurrence of electrochemical process within a definite potential range. So left side of this slide, we are seeing standard electron potential, though I have some exception to explain. In case of alloy formation, these particular processes are really independent from each other. In many cases, a mutual influence of this process is observed, though on the whole, their nature and kinetics in general remain unchanged as compared to individual deposition. So let's talk about significance of alloy electrodeposition. In short, electrochemical alloys often present properties and performance that are several times better than those of the individual component, even in comparison to metallurgical alloys. This is true in particular in regard to wear resistance, hardness, and corrosion stability. At present, there are hundreds of alloys obtained this electrochemical method. These widest pairs are the alloy based on the metals on the iron groups. First, let's see copper and noble metals role of static potential. Now let's we can see at left side of the slide that hydrogen deposit at a much more negative potential than its equilibrium value. So we have red sign to show you that just that hydrogen comes standard electrode potential, that this existence of this phenomenon is fortunate. So why deposition? Because the majority of the metals in which electroplates are interested have potential less noble than of the hydrogen. So as a rough cut, we have some exception also, but roughly reasonably satisfactory deposition will occur if static potential of the metal are less than or equal to 0.2 volt. The right side of the slide, the predictions concerning alloy deposition from electrode potential alone are not wholly reliable because many unpredictable specific effect occurs with each pair of metals. We are seeing zinc, we are seeing vanadium, germanium, tin, lead. With hydrogen deposit more than manganese about that zinc. Advantage of alloy deposition: increase corrosion resistance, combination of properties, new properties and tailored properties. Okay, advantage of this disadvantage of alloy deposition. We're seeing three disadvantages: greater control required, difficult of reproducing alloy composition, greater adhesion to anode system. Okay, sixth principle of alloy electrodeposition. No, I am just explaining one or two, so because of short of time. in a plating but is finished with two metals at a constant ratio m by n, which the ratio of the metals or ratio of the metal will be m by n. Increasing in percentage metal and its ratio in part result in an increasing in percentage metal and its ratio. So 3, the ratio of concentration of more readily disposable metal to the other is smaller to the cathode solution interface than in the body of part. So 4, 5, 6 I'm not reading, I'm just seeing this. So plating variables. Variable A, variable of the bath composition. Number 1, concentration of the disposable metals ratio of concentration of the disposable metal total two ratio total concentration of the disposable metals. 2 number, concentration of complexing agent. 3, pH of bath plating bath. 4, presence of adding agents.
4 minute.
Plating variable B হচ্ছে variable of bath operation, current density, temperature and bath evaporation. Miscellaneous variables such cathode current, efficiency, shape of cathode, deposit thickness, type of current. So alloy types of alloy plating system. Data on this effect of the variables on the composition of electrodeposit alloys constitute a mass array of details. Theoretical discussion of this data are greatly simplified into 5 types. I'm not explaining, just putting the names of this: regular co-deposition, irregular co-deposition, equilibrium co-deposition, anomalous co-deposition, induction co-deposition. So from 1 to 3 is the normal alloy plating system, but for 4 to 5 is for abnormal alloy plating system. Okay, now I am finished. Thank you.
থ্যাংক ইউ। তুমি ওই পয়েন্টার ইউজ করো না কেন? পয়েন্টার ইউজ করলে বুঝতে আরো সুবিধা হয়। হ্যাঁ,
Sorry.
পয়েন্টার ইউজ করবা সবসময়, ঠিক আছে?
জি।
ওকে, এভাবে আস্তে আস্তে ইমপ্রুভ করার চেষ্টা করবা। তোমার রোল নাম্বার হচ্ছে 33, তাই তো?
জি স্যার।
ওকে, আমাদের শেষ হলো। থ্যাংক ইউ এভরিবডি। আমাদের নেক্সট মঙ্গলবারে আবার রেগুলার ক্লাসে দেখা হবে। ভালো থেকো সবাই। ওকে, আল্লাহ হাফেজ।
আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম ওয়া রাহমাতুল্লাহ।